away we go. Alright, so let's get cracking. How is everybody? How are we all doing? Hopefully alright. It's Friday. It is the day before the weekend. It is the last day of the week. Almost can breathe a sigh of relief. But yeah. This video is going to be talking about units, okay? And how changing units and thinking about us converting units doesn't need to be difficult at all, okay? And in fact, with the metric units that we work with, they're actually really, really useful and really probably the better units to be working with, okay? We're going to take a look at one of the particular measurements in the metric system. We're going to see how it works. We're going to then stretch it to apply it to all the other units in the metric system, or at least the majority of the ones that we will need to use, and then think about how can we then continue to use these to, change units of area, units of volume, all this kind of stuff as well. So we're going to go like a proper full dive into this. Okay, and I'm going to kind of point out at certain points where things are going to kind of step up a little notch. Okay, and the first thing that we're actually going to do, believe it or not, isn't actually maths. Okay, the first thing that we're going to do is talk a little bit of English. Okay. So what gives you the biggest clues to looking at units are what we call a prefix, is a kind of a section before a word, okay, or something that comes before a word. For example, in centimetre, centi is a prefix to meter. It's a bit that goes before another key part of that word. Okay. And we have different prefixes, okay, depending on the amount of something that we're talking about. Okay. So at the top, or at least at the top of the ones that we will think about, we have the prefix kilo, thinking about the word kilometer or, kilometer. Okay. What that means is that means we have 1,000 of something. So if we're talking about a kilometer, we're talking about 1,000 meters. Okay. We have the word like just meter by itself. We have centi. Okay. Now, that word cent, you're thinking about currency, you're thinking about money, you'd think that there are 100 cents in a dollar or 100 cents in a euro. Okay. So a centi is talking about 100th. Okay. Not 100. Okay, because a centimetre isn't 100 meters, it's 100th of a meter. Okay, so I'm just going to put 1/100 just to kind of emphasize what I mean there. Okay, so we've got kilo, which means 1,000, centi, which means 100th. We also have milli. Okay, now that word you might think millennium, you're thinking like 1,000 years or something like that. But in terms of measurements, if you're talking about a millimetre, we're not talking about 1,000 because we've already got that. That's kilo. We're talking about 1,000th. I've got a feeling that there should be a D in there. 100th. 1,000th. Yeah, I think there should be a D in there. Anyway, 1/1,000. Okay. So we got different prefixes depending on how much of something we want to talk about. Okay, and it's important, or at least it's very useful for us to be able to know what these things mean, because then it can give us a sense of how much of something that we have. Okay, so those things, those are useful. But we want to talk a little bit more about the mathsy side of things. Okay, so let's think about this in terms of the maths now. So we obviously have like a chain of scale. Okay, we have a kilometer, which is in terms of what we think of, that's kind of our larger units of distance. Okay, we have a meter, then we have our centimetres, and we have millimetres. Okay. Now, we can obviously get bigger than a kilometre and we can get smaller than a millimetre, especially when you get into the kind of sciencey kind of world. You get things like nanometers, which are really, really small, and micrometers as well, which are not quite as small as a nanometer, but still pretty small. But these are the ones that we're going to focus on here. Okay? And everything comes from the point where we just have the word by itself. Okay? So if we're talking about a meter, we've got 1 meter. Kilo means 1,000. So this is talking about 1,000 meters. Okay? So to go from a kilometer to a meter, I would have to times by 1,000. Okay? Because the factor of what we're talking about is 1,000. If we have 1 kilometer, we would have 1,000 meters. Okay? And if we were to do the opposite, if we were going from meters to kilometers, if I've got like 2 meters, that should be a really small amount of kilometers, so I would have to divide by 1,000. Okay? So a kilometer is 1,000 meters. So that would mean that to go from kilometers to meters, I would times by 1,000. To go from meters to kilometers, I would do the opposite. I would divide by 1,000. Okay? So now, let's think about some of the smaller ones down here. If I wanted to go from a meter to a centimetre is 100th centi, meaning 100th. A centimetre is 100th of a metre. Okay, so there are 100 centimetres in 1 metre. Okay. So if I want to go from meters to centimetres, I would have to times by 100. If I wanted to go from centimetres to meters, I'd have to do the opposite of that. I'd have to divide by 100. Because if you have lots of centimetres in meters, that would be a much smaller number, because we'd need fewer meters to do the same amount as lots and lots of centimetres. Okay. Now we can also go from a meter. I'm going to bring this arrow out to the side so that we can see here. We can also go from a meter to a millimetre. A millimetre, milli, is 1,000th. So there are 1,000 millimetres in 1 metre. And again, we could do the reverse of that if we wanted to. We would have to divide by 1,000. So hopefully now we can start to see how these prefixes, these key parts of the word, tell us how the conversion works, okay? And it always depends on what your prefix is. So let's just go, for example, if I was doing meters, if I had 10 meters and I wanted it in centimeters, so 10 meters equals how many centimeters? There are 100 centimeters in a meter. So that means that I would have to do how many meters I have times by 100. So that would give me 1,000 centimeters. Okay, 10 times 100. Okay. Now, if we were to look to find out some of the little bits in the middle, we can do that, okay? The only one which we've not really covered here is looking at centimetres to millimetres. Now, to get from metres to centimetres, we would times by 100. To get from metres to millimetres, we would times by 1,000. If we're to go all the way down this chain, it should be the same as timesing by 1,000. So to get from timesing by 100 to timesing by 1,000, I would have to times by an extra 10. And if we look on a ruler, the normal standard ruler, we have our centimetres, 1, 2, 3, 4, 5, so on. In the little divisions are our millimetres, and there are 10 of those to make up 1 centimetre. Okay, and we could obviously do the reverse by doing the opposite of timesing by 10, which is to divide by 10. Okay, so let's go through a couple of examples. So 5.5 kilometres equals how many metres? So kilometres to metres, kilometres, 1 kilometre is 1,000 metres. That's what the word means. Kilometre means 1,000 metres. We then are going to say, if there are 1,000 metres in a kilometre, I would need to take this and times it by 1,000. I get 5,500. If I wanted to convert 2.4 meters into millimeters, milli means 1,000th of a meter, so that means that there are 1,000 millimeters in 1 meter. So again, I would need to times by 1,000. So I'm going to have 2,400 millimeters. Okay. Now, this is what's awesome about metric units, okay, and why they are significantly better than imperial units. I can now change out the word meter for gram, and I'll be dealing in weight. I could change out the word meter for litres, and I'll be dealing in volume, or excuse me, not volume, but capacity, okay? You can change this word out. All of the conversions stay the same, okay? So if we were to suddenly say, okay, I want you to change 320 grams into kilograms. Well, kilo is 1,000 grams, so to go from grams to kilograms, I would have to divide by 1,000. The conversion is exactly the same, we just swap the word out. Okay, and that's what's really good about metric units. Metric units are extremely straightforward to work with, because if you know one conversion, you know them all. Okay. And one final example. Let's go for 0.032 milliliters. No, let's change that. 0.032 liters is how many centiliters? Now, centiliters isn't a unit that we use very much, but it is a unit, so we can look how to convert it. Well, meters to centimeters, centi is 100th, so there are going to be 100 centimeters in 1 meter, which means that to go from liters to centiliters, we would also times by 100, because the conversion is the same, it's just the word that is different. Timesing by 100, the place values shift along once, twice, so we're going to have 3.2 centiliters. Okay? And doing all of these conversions is really important. It's a really essential skill. Okay, if you're looking to do any kind of like building work, measurements, anything like that, you need to make sure that all of your units are in the same format. You need to make sure that your measurements are consistent. You need to make sure, like, if you're doing science experiments, that the amount of liquid that you need to fill a beaker or any kind of test tube or something like that is in the right unit. And if it's in different units and you need to know it in a particular one, then, you know, doing this will help. Okay? Knowing the prefixes is a useful help thing. Like, it's not essential, but it is really useful, I think. Knowing the conversions is what's particularly important. Hang on a minute. Someone's at my door. Sorry about that. Right. So, that's kind of what we do there. Right. That's our converting basic units. Okay, we need to be able to do that. Okay. Now we're going to step things up. Okay. We're going to talk about area. Okay. So let's stick with a nice example. Let's stick with a rectangle. Okay. Now, let's say that this rectangle is 3 centimeters across and 2 centimeters up. The area of this rectangle would be 2 centimeters times 3 centimeters. 2 times 3 is 6. And when we've done a centimeter times by a centimeter, we have centimeters squared. Okay. Now, when we're looking to change our units for this, we could draw exactly the same rectangle, but this time have the units be different. We could have it as 30 millimeters and 20 millimeters. It's exactly the same rectangle, because 3 centimeters will be 30 millimeters, 2 centimeters would be 20 millimetres. Okay, so this time the area would be 20 millimetres times 30 millimetres. 2 times 3 is 6, but this time it's going to be 600 millimetres squared. Now something here is a bit different, okay, because to go from centimetres squared to millimetres squared, we didn't just times by 10. We timesed by 10 twice. Okay, essentially we timesed by 10 squared. Now the reason for that is because we have done a unit squared. So when we do our unit squared and we change it, our scale that we times by also gets squared. Okay? And this is something which is initially a little bit odd, a little bit confusing, but we're going to have another look about why. So this is our kind of first little step up. Okay? I'm going to have to shift that back down. We're going to use some more paper up here. So units of area. So let's have a couple of quick examples. So let's say that we have 3 meters squared, and I want to convert it into so many centimeters squared. First of all, we need to know what the conversion is for our just normal meters, okay, and why it's especially important to know these. Okay, meters going into centimeters, we would times by 100. Okay, so 3 meters squared would be the same as 3 times 100 centimeters squared. Okay, where there was a meter, I've just replaced it with 100 centimeters. Now, this means that our 100 is going to get squared and our centimeters are going to get squared. Okay, both of those things there are going to get squared. So this is going to be 3 lots of 100 squared centimeters squared. When you have something squared, it timeses by itself, multiplies by itself, not timeses. So we're going to have 3 times 100 squared, or 100 times 100, okay, which is 10,000. 3 lots of 10,000 is 30,000 centimeters squared, which is a lot, okay? Because of that squared there, not just our units get squared, but whatever we would normally multiply by also gets squared, okay? And if you want some proof, we can actually prove that, okay? We can think about it in terms of an actual shape, okay? So let's think of something that would make 3 meters squared. So let's say like 3 meters long, 1 meter wide. In centimeters, that would be 300 centimeters long and 100 centimeters, like that. Ooh, centimeters. Now, the area here is just going to be 3 meters squared. And the area here will be 3 times 1 is 3. 1, 2, 3, 4 zeros. 30,000 centimeters squared. Okay. Now, just a little bit of a pro tip. If you are finding like the area or a volume of a shape and you've got different units, convert your units before doing your calculation. It will make things easier rather than converting them after you've done your calculation. But if you already have an area or a volume and you need to convert your units, then this is pretty much the way that I would go about it, okay? Think of it in terms of like this. And if you have studied your index laws, okay, that is what's going on there, okay? If you want to know why this thing has worked, you might want to look into your index laws, okay? Now, we're going to look at our final little step up. We're going to think about volume. Now, let's think. Let's say we have a hole in the ground that is 5 meters cubed. Okay, so it's a reasonable hole. And we want to know what is it in, I don't know, millimeters cubed, just to be awkward. I can't think of a situation where you'd want this, but we're just doing it to show that we can, okay, if we ever needed to. First of all, we need to think about the conversion. Meters to millimeters. Millimeter, milli, is 100th of a meter. No, not 100th. It's 1,000th. It's 1,000th of a meter. So there are 1,000 millimeters in 1 meter. So to get from meters to millimeters, we would times by 1,000. That's from meters to millimeters. So 5 meters cubed would be the same as saying 5 times 1,000 millimeters cubed, using the same technique as we did before. Now, as before, when I brought that squared inside of the bracket, everything got a squared, not just the unit, but the conversion did as well. So we're going to have 5 times 1,000 cubed millimeters cubed. Okay. 1,000 cubed. So that is going to be 1,000 times 1,000 times 1,000, which is going to be a 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. That's a lot. That is that's a 1,000 million billion. That's a billion. So our 5 meters cubed is going to be 5 times a billion, 3, 4, 5, 6, 7, 8, 9 millimeters cubed. Now I'm just going to write that as 5 billion. Millimeters cubed, which is ridiculous. That is a lot, and is why you probably would never look to convert 5 meters cubed into millimeters cubed. You just wouldn't need to. Okay, but the point is not that we wouldn't need to, but that we can if we needed to. Okay, if for some bizarre reason we found that we needed to, we now can. Okay. And it all depends on what your original conversions would be for like a single meter, not meter squared or meter cubed, but if you know these conversions, you know them for liters or grams or anything like that, but you also know what conversion factors you need for area and for volume as well. Okay? And that's why metric units are really, really useful. Okay, in my opinion, much better than some of the imperial conversions that we still sometimes use. Okay. So, in what kind of order would I look to start trying to commit things to memory? Okay. This is the top bit with the English. It's kind of cool if you know them, but they're not essential. Okay. This would be the first thing that I'd look to know. Okay. What the conversions are for each individual unit. Knowing the prefixes will help, definitely, but this is what I would look to know. Then I would look to be able to convert with just normal units of length or mass or something like that. So kilograms or grams or litres and milliliters, things like that. I would then look to be able to do this. Then I would look to be able to work with my units of area. So can I make this step happen here? Okay, knowing your index laws will help with that, but as a shortcut you can just say, if I've got something which is a bracket squared, then everything in that bracket should get squared if they're multiplied together like we have here. Okay, and then this, the very end, is where I would look to finish off. Okay, now these last little bits are normally kind of your kind of higher order skills on a foundation paper kind of thing, in terms of like what you can do with units. There are certainly other challenging aspects to a foundation paper, don't get me wrong, but in terms of units, this is generally as far as you will look to go on a foundation series. On higher, you might have to combine some of this with some of your compound units, so things like density, force, pressure, speed, all those kinds of things. They might get combined in with some of this as well. So, knowing this is definitely useful. Okay? And I know that this was a bit of a Mr. Hughes talking at the paper, but it's something that is probably best looked to understand, practice in a separate time. Okay, you can feel free to like keep this up or make notes from what we've written here, and then go and look to practice these things yourselves. There are loads and loads of quizzes on the Hegarty to do with converting units, of which I kind of detailed in an email. And also you've got exercises on Corbett Maths as well for dealing with units. Okay? And I am going to leave it there. Okay? And I will say see you in the next one. Ta-ra.